Hello class, in this video I'll be doing an example on how to find both first order partial derivatives where the derivatives require the chain rule. Let's begin. So at the top I have the chain rule written down and I'm going to highlight it in blue. Now this is the chain rule for when the function is structured as a power rule. And I'm going to use this rule to find the partial derivatives of this function right here, starting with the partial derivative with respect to x. And remember, when you're trying to find the partial derivative with respect to x, you're going to treat y as a constant or y as a coefficient. So I'm going to go ahead and rewrite this function so that all coefficients and all constants are in pink. So for the first term, 7 is the coefficient of x squared. In the second term, 12y squared is the coefficient of x. And the third term is going to be treated like a constant. And now, to find the partial derivative with respect to x, I'm going to apply the chain rule. So the 1/3 becomes the coefficient. The expression inside the parentheses is going to stay inside the parentheses, just like that. And I'm going to subtract 1 from the exponent. So that becomes -2/3. Now, I need to multiply this by the partial derivative of this trinomial with respect to x. So the first term, the partial derivative with respect to x of the first term is going to be 7, then times 2x. The partial derivative with respect to x of the second term is going to be 12y squared, because 12y squared is the coefficient of x. And the partial derivative with respect to x of y cubed is going to be 0, because y cubed is a constant. So to clean that up, we have the following. And now we can evaluate this partial derivative for when x is equal to 3 and y is equal to -1. So I'm not going to show you the substitution step. I will, however, write out the value of each term after substituting in the appropriate numbers. So after substituting 3 in for x squared, you get 63. So after substituting -1 in for y and 3 in for x, that's 36. And then the final term is -1. 14 times 3 is 42. And 12 times a +1 is going to be 12. This is going to equal 54 divided by 3 times 98 raised to the -2/3 power, which is equal to 18 times 98 raised to the -2/3 power. And if you're asked for a decimal approximation, you can just type this solution into Decimus and get a decimal approximation. Okay, now on to the partial derivative with respect to y. Okay, so when we take the partial derivative with respect to y, we're going to treat x as the constant, or we're going to treat x as a coefficient. So what I'm going to do is I am going to write all of the constants and all the coefficients in green. Okay, so the first term, the 7x squared, that entire term is going to be a constant. In the second term, 12x is going to be the coefficient of y squared. And in the third term, y cubed is a variable. So now we're going to take the partial derivative with respect to y. And that means we're going to apply the power rule to the original function. So the exponent becomes the coefficient. The term inside the parentheses stays inside the parentheses. And we're going to subtract 1 from the exponent. Now the derivative of 7x squared is 0, so I'm not going to write it. The derivative of 12xy squared with respect to y is going to be the following. So since 12x is the coefficient, that gets written down first. And the partial derivative with respect to y of y squared is 2y. And then the partial derivative with respect to y of y cubed is 3y squared. So the partial derivative with respect to y of the entire function is the following. And now we can evaluate this partial derivative when x is -2 and y is 0. And just like the previous problem, I'm not going to make the substitution steps, but I will write down the result after making the substitution. So 7 times 4 is going to be 28. The next two terms will be 0. And then in the braces, the first term is going to be 0, and the second term is going to be 0. So this result is just equal to 0. And we are done.